Okay, so reminder, numero uno, the assignment on the top before we even get started. Okay, this is going to be in homework check number 3. This is the 4th and final assignment from that. So by Thursday, we'll need to have this under control, but again, tomorrow we're going to spend some time going over questions and going over some more stuff with that anyway, just to be sure. Okay, piecewise practice is kind of a combination of substitution with evaluate and graphing lines, which is why I'm harassing some of you so much about knowing how to graph a line. Because if you don't know how to, this becomes a very tricky proposition. So we'll kind of see as we're going through here, but I've got some ways to try and help you out in case that's a struggle for you. So here we go. All right, in real life, and we'll get into some life applications of this as well, we get represented a combination of equations, more than one. Sometimes it may be 2, sometimes it may be 3, so on and so forth. So what they're called is piecewise functions because we take them in pieces and we do them. So here's how these work. You're going to be given an f of x, a function, a set of expressions, and your job is going to be to figure out where these values plug in correctly to that. Okay? We're going to start without doing it with a graph because it's a little bit easier when we just substitute. So here's how this goes. The first thing I always have to look at is going to be the if part, because the if part tells me which expression that I need to use. Okay? So when I'm looking at my numbers, 10, negative 1/3, it's only going to work with one of those two. It's not going to work with them both. So what I want to do here is, my first question would be, so x equals 10. If I'm just looking at those two inequalities, which one does the 10 fit into?
Excuse the interruption. Is Colin Trollope in the room?
Yes.
Did you send him?
Is 10 less than or equal to 4? Oh, good. I was afraid that it was like an optical illusion that I was here by myself for a minute. No. Is 10 greater than 4? Yes. Okay. So once I realize, okay, 10 works in this one, what that means then is the expression that's next to it, that's where I'm going to plug the 10. So wherever the x is in there, I'm going to plug that 10 in, and I'm going to get my answer.
Why 10?
Because they're giving me the x value here, so my job is twofold. One, I use the if statements to let me know where this 10 fits, because the 10 will only work and make one of these true. Once I figure out which one's true, then the expression that goes with it is the one that I'm actually going to substitute into. So like, if we're doing it on this next one for number 2, I go, okay, negative 1/3. Is negative 1/3 less than or equal to 4?
Yeah.
Yes. Okay. So this time, I'm going to use the top one. And the top one's expression is 3 times x, but that's negative 1/3 this time, minus 1. Okay, it'll only work in one. We'll never have it where we do it in both for any one of these. And before some of you freak out with a fraction, remember, oh, I'm multiplying, those would basically just cancel. So all I'd be left with is the negative 1 that's up in the numerator, minus 1. Get my negative 2, and I'm good. But again, it always comes down to that first part of figuring out which of the if-then statements does it go with. Now, number 3, be careful. My x value is 4 for this one. Which one of these works if I plug in 4 for x? The top one, because it has the or equal to. Okay, 4 isn't greater than 4, but 4 is equal to 4. So I'm going to be using the top one for this one. And again, I just look at the expression, And if there's an x there, I'm going to plug in for it. So 3 times 4 is 12, minus 1 is 11. So it's just a thing of figuring out which one am I using and then plugging it in. Now let's do one more. X is negative 2. Which one of these does negative 2 fit into? The top one, because negative 2 is less than 4. You're like, dang, a lot of them are doing that one. So again, plug in the value. Again, we're on the top one here. And again, this is where if you do all this right, be very careful with your details. 3 times negative 2 is negative 6. And if I owe somebody $6 and I owe them another, now I owe them 7. Don't get the hard part and then mess up with a sign somewhere because we're going too quick. Okay? But that's all we're up to up here. Look at the ifs to figure out which one your number fits into, and then plug it into the corresponding expression. Now, are they always going to be that straightforward with only one function? Unfortunately, no. Sometimes we're going to have multiple functions. Oh my. F and G and H. Now again, we're not using them all at once, but I have to pay attention to the letter in front because the letter in front is going to tell me which function I'm working with. So for instance, alert. 1 through 4, notice they're all F's. So we're going to just be using this one for 1 through 4. And there's another part that gets interesting, but we'll get there in a minute. So, all right, here's my if statements. If I plug 2 in, the number in parentheses, for x, which one does it fit into properly? The bottom one, because 2 is greater than 0 is. Okay? So I'm going to use the one on the bottom. And you're like, well, wait a minute. There's nowhere to plug a number. It's just 2. Do I do 2 times 2? No. There's no place to put x. You just write what you see. 2. So the nice thing about these 4 is that the answer is either going to be 2 or 3 because there's nowhere to plug a number in. That seems kind of weird at first, but then you start to think about it. You're like, well, I guess. I'll show you a graph of it here. I don't know if it's going to be today or tomorrow, but we're going to see one that we look at. It's just like that. Okay. Next one, same idea. Negative 4. Which one does negative 4 fit into? The top one, because negative 4 is less than 0. Okay, so that's going to be my top one. And, well, it's just 3. Okay. There's only 2 answer options on that first one. Nothing to even plug into. All right, one more f. F of 0. Top one, because again, 0 isn't greater than 0, but 0 is equal to 0. So the top one gets me to 3. Like, all right, it's not terrible. So then I see the next 4 here start with G. So that's going to be where 5 through 8 are. Now this time there's actually some place to plug X, so we can actually get something going here. But here's my ifs. All right, so G is 7. 7 isn't less than 3. 7's greater than 3. Okay, so it's the bottom one. So I'm going to plug in that 7 where the X is at. Okay, so this is my expression that I'm using. I'm just plugging in that 7 instead of the X. So 14 minus 1 is 13. Okay, so again, which statement is true for my if, then plug it in. What about G of 0? Top one, because 0 is less than 3. So I just plug in the 0 for x. 0 plus 5 is 5. And I'm good. So again, don't let it be that there's several steps get you. It's only 2. Which inequality? Plug it in. All right, let me hit a couple of H's because I like dealing with these fractions. So for H, that's what our 9 through 12 would be here. H is negative 4. Remember, Here's where we always start. Top or bottom for -4 for my x. The top, -4 is less than -2. Okay, if you even need to look at a number line on these to kind of think about it, or think about money, you know. -4, I'd rather not owe somebody $4 rather than 2. So we're going to the top here. So if that's the case, oh, fraction. Oh. Again, don't worry. Just give yourself a minute to think. Half of 4 is 2. I know you know that. If I owe somebody $2 and I go borrow 4 more, I owe them more. I owe them 6. Again, don't let yourself worry too much because it doesn't do any good for you. What about number 10? Which one, which one, which one? Top. Because again, there's that -2. -2 isn't greater than -2. It's not less than -2, but it is equal to. So we do this one more time with that fraction that we are not going to fear. Half of 2 is 1. -1 minus 4 is -5, and we're good there. Any issues so far with our piecewise just figuring out some expressions here? Look at the if statement, figure out which expression to use, and then just do a little substitution. They're like, maybe. All right, so far. Okay, now comes the part that's interesting. Now we put what we just learned with graphing. Graphing lines. And I said this second, I'm going to say it again. If graphing lines is still giving you issues, you better like live with me on some of this stuff for a few days because we have got to get to a point where we can do these. So I'm going to show you 2 ways you can do this. You can...
This would be part 2.
So yeah, part 2 of the part 1. Okay, never mind. So, okay, here's how this is going to work. She's going to show you 2 ways to do this. If you're comfortable with graphing lines, I think you're going to be very much preferred to doing this the first way. If you do not have a pencil right now, watch me do it before you write anything because I'm going to be erasing stuff. So here's how we're going to do this. Okay, first we're going to draw the line. Then we are going to erase the part we don't need. Like, wait a minute, part we don't need? Right, because that little if thing that we keep talking about, yeah, this right here, that's the part that I'm talking about. So here's how this works. Okay. First things first, I'm going to graph my first line. My first line here is going to be my pencil mark. I'm going to start doing colors here in a minute. Some of you might find that having a colored pencil or two might be a good thing for this. And I apologize. I normally have a big box of them, but I must have it over in the workroom. I'm going to graph this line. So first things first, my y-intercept. Say this again. Y-intercept. Okay, -1. Don't put that on the x-axis. That first point should be on here somewhere. Then my slope, remember, is a fraction if I don't see it to be 1. And I'll even zoom in a little more here with these. I'm going to go up 2 and right 1. Don't be content. I want you to go dot crazy. Keep going up 2 and right 1 until for right now you run out of room. When you run out of room with these, going up and to the right, I want this going the other direction too. So we've got to think about this for a minute. We're like, okay, so if I'm going up and right, if I do the opposite of both, I should be on the same line. So let's see. Up and right, down and left. So down 2 and left 1. And I'm going to do that until I run out of room. So I'm going to have this line that's nothing but dots going all the way across here. Once I get that, here comes the erase the part we don't need. This if part. If x is less than or equal to 1. Couple of things here. First, I got to find where x equals 1. Okay, here's where x equals 1. There's my point, where x equals 1. If it's or equal to, if there's a line underneath, that's going to be a filled in dot. I've got it drawn over there on the board too, and I'll write it on here when we get a chance in a minute. But if it's or equal to, we fill in the dot. If it's not, we're going to have a circle, but we'll get to the circle one. X is less than 1. Do I need to work with my points to the left of my dot or to the right? Where do my x values get less? To the left. So every one of those points to the left, I'm going to connect and draw my line. If you're one of my dots that's to the right of x equals 1, you are going to disappear. You don't exist to me. That's the only part of the line I want. So when you're doing these, you'll always have a dot on one end and then an arrow on the other. But it all depends on which part of the line you want based on the if. Now, like I said, I'm going to do my second one in color once I'm done. I'm not going to do it in color right away because, well, if I screw up, that's going to be kind of sucky. So we got to do this again. Graph another line.
Wait, why do you have a dot above the y-axis?
This one?
Yeah.
Okay, because when I graphed my line, my y-intercept was at -1. And then since my slope is 2 over 1, I kept going up 2 and right 1, up 2 and right 1, and so on. But the only part of the line I want is the part that starts at 1, because x is less than or equal to 1. So since this is where x equals 1, that's my first dot, and then I just go from there, and I don't want the rest here. I'm going to do the same thing on this one. My y-intercept's at 1, so I'll put a dot here. Then my slope, remember if it's not a fraction, I can put it over 1, is up 3 and right 1. It's just like before, up 3 and right 1. Make as many dots as you can. Now this is going to get a little squished here, so we got to be careful. And then I'm going to go, instead of up and right, just like before, I'm going to go down and left. 1, 2, 3, 1. I'm going to try to make it where I can still see them. 1, 2, 3. Ooh, okay. It shares a dot with this one. That's okay. 1, 2, 3, 1. So I'm like, okay, it's kind of going like this. But now we got to go back and look at the restriction. If x is greater than 1, okay, so here's x is 1. There's my dot on this line. Again, it needs to be an open circle on that point. Okay, that's the start of my graph. But since there's no line, this has to be open to say I don't want this value included. And greater than 1 means I'm graphing to the right of this. I want the points that are going to the right of that dot. If you're a point I just made on this line and you're to the left, I don't need it. And that's my graph. And it's called a piecewise function because, as you can see, it's a line that's broken into pieces. Business applications here. Where's my break-even point? Or after I sell so many of it, then the price goes up. That would be a gap that would be in there, and this allows us to do that. Now, some of you are looking at that and going, okay, even the line thing had me confused. Now the fact that we're erasing part, what the heck? Is there another way? To which I say, yes. Yes, there is. Now, it takes a little longer, but it works. So here's what we're going to do. We're going to kind of combo some things here. We'll take this a piece at a time again. So I'm going to start with the top one. All right. 1/2 x. I don't see a y-intercept. What's my y-intercept if I don't see one? 0. Okay, so plus 0. Right there. Okay. And then I'm going to do my slope. Now, if this whole thing just, you're like, I don't graph things well, I need help. Okay, here's our help. Here's what we can do. We can make a chart. And here's how the chart would work. And if some of you are comfortable with just the line, I say you keep doing it that way. But if you're going to chart it, here's how this will work. All right, I'm going to put my expression right above here. And whatever number's here, okay, x is less than 1. I'm going to start with that number. X is less than 1. So if I start counting down from 1, what's going to come next? 0. And then like -1, and I'd probably go to 4 numbers. So I'd say, okay, if it's less than, I'm going to go down 4. Now I have a choice. I can either do mental math, 1 times a half, okay, so that's a half, 1/2 times 0, because I'm substituting, 1/2 times -1, and some of you are saying, wow, this is kind of a lot of work, isn't it? Half of -2 is -1, and I can plot the points. It might be, but again, if this makes more sense to you and you're going to make an accurate line graph out of it, then do it. Here's your other choice with that way of going. You could hit y equals and graph 1/2 x. Okay, now, you're like, but that makes the whole line. How do I know, where to stop? I agree. So here's what you would do. Instead of just hitting graph once you plugged it in at y equals, you'd hit second graph. Oh, it gives me a chart. Right, because now I can look and I can say, okay, well, it starts at 1 because this number tells me that. So that'd tell me I put a point at 1/2, like we did here when we substituted. And you can just work your way up the chart getting the values that you want. Notice I got the same values in my chart that I have over here. 0, 0, -1, -1/2, -2, -1. And I even have more points if I want them. This way I don't have to worry about erasing stuff. I just take the points and I say, okay, so 1, 1/2. Now before I put this point, open or close circle? Open, okay? That's going to be an open circle. So right at 1/2, get my big circle there. 0, 0, I already plotted. -1, -1/2, I'll put a little dot. -2, -1, I'll put a little dot. Once you have about 3 dots after your initial, you don't have to keep going. I mean, I can see it on my screen right now, so I'll make another couple. -4, -2, okay. And then I just connect those dots, and I don't have to do any erasing. Because the only numbers I'm putting in my chart are the ones that are, well, less than 1. Okay, I don't have to do all the other ones. And I can do the same thing with the other one. I could have -x plus 3 and do the same thing. Now let's save us a little bit of time this time. If we plug it into the calculator, -x plus 3, and do our chart again, I know I'm going to be starting at 1. Okay. If the values are greater than 1, what numbers should come next? We're looking for values greater than 1. Count up. Okay, 2, 3, 4. So let me get those up where I want to be able to see them. So now I can be like, okay, I know what numbers I want. Oh, I can just look at the screen. 2, 1, 0, -1. Okay, let's do this. Now, at x equals 1, for my bottom one, for my -x plus 3, is this going to be open or closed? Closed because we have the line underneath it. So I'm going to go to 1, 2, right 1, up 2. I'm going to put a closed dot. And now I'm just going to start plotting these other points. So 2, 1, 3, 0, 4, -1, and I'm going to connect the dots from my first one. Again, I'll always have a dot at one end and an arrow at the other. Okay, it'll never be arrows both ways. So again, you have a choice. I don't care if you draw the lines and erase parts if you're good with graphing lines. If that's not your strength, use the calculator or use mental math. These aren't ridiculously big numbers. You could do these in your head. And then just plot the points that you need to get it started and go. Okay? Now, we're going to take a look at a couple more anyway, just to make sure things are going all right here. And I'll do one more each way, okay? 15 I'm going to do just by drawing and erasing, and then 16 we'll do with the charts again. And by then, you'll probably have a pretty good idea which way is going to work best for you. So let's see, 15. Okay, we'll start here. So my y-intercept is at 2. And then my slope is 1 over 1, because I don't see any numbers in front of x. So I'm going to start going nutso with my dots here. So I'm kind of going and going, up 1 over 1, Now before I start going crazy the other way, let's think about this for a minute. If x is greater than 3, open circle to the right, because greater than means my values are getting bigger. If my values are getting bigger, that's what happens to the right. So do I even have to make all these dots over here? No. I'm going to go to where x is 3. Okay, here's where x is 3. I'm going to go up to my graph. There it is. And I say, oh, it's got to be an open circle. Okay, hang on a minute. Let's turn this into open. Open circle. And to the right. Connect the dots. Erase the few others that I have here. Okay. And I've got the first part done. Same thing on the next one. My y-intercept, that number on the end's at -3. Remember that first dot, unless you're doing the chart, it's going to be along here somewhere. So down here, put my dot. My slope's 1 over 1 again. Now, before I get going here, rolling along, going up, 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 what do I want again? I get going, I'm like, wait a minute, let me think about this. X is less than or equal to 3. Well, I know my dot's going to be closed at 3. Here's 3. Okay, so that dot's closed. But then less than, oops, means I'm going to be going to the left, because that's where my values of x get left. So I'll connect the dots going to the left. Erase those other two guys, and I'm good to go. And there may be some times that these two guys share a dot. One's open and one's closed. That's okay. Okay, just trust yourself on these. If you graph your lines correctly, this is going to go well. But you got to make sure the lines are going well. And again, like we said before, if graphing lines is still a struggle, besides the fact that we need to get in here so we can make it where you can just draw a line, here's the other part we need to know. So if we're still struggling here, and we're going to go the chart, which is okay, I'd say, okay, I know I'm starting with 1 because that's the number in my problem. X is less than or equal to 1. Less than means my values are going downward. Okay, so either, again, I can use the calculator, or, I mean, this is easy enough. I can do this in my head. 2 times 1 is 2. 2 times 0 is 0. 2 times -1 is -2. 2 times -2 is -4. And those are my coordinate points that I'm going to use. So I'm like, okay, 1, 2, 0, 0, -1, -2, -2, -4. But is my dot at 1 going to be open or closed? Closed. So that stays closed. I'll make it a little bigger. And that's always where my line is going to start, here. So if it starts here, and then I just connect the dots to the rest, and that'll determine the direction it's going to go. Okay. Don't look at it and think like, oh, it's positive, so I got to go. No. That's my dot, starting point, and then just connect the dots from there. And then we're going to do the same thing with this one, and then we'll see where we're at here. All right, so x and y, we're starting at 1. X is greater than 1. We already know this is going to be open because it's not or equal to. Greater than, the numbers go up. Now, if this starts to get you a little, I hope it doesn't, 1 times a half is a half. So a half plus 2 would be 2.5, or you could write 2.5. I'm good with that. Half of 2 is 1. So 1 plus 2 is 3. Maybe you can see a pattern develop. Okay. 3 times 1/2, if you plugged it in the calculator, would be 1.5. And again, if you need to plug this in, if the fractions are going to irritate you and bug you and drive you crazy, don't let that happen. Okay, clear it out. And whether you're literally going to plug this in this way, because I know some of you are going to come up, you're going to go, but I don't have a graphing calculator. You don't need one. Okay. Now, if you have one, take advantage of the fact that you can just look at the numbers and plug them in. Okay. I just did that here. But if you don't, okay, so what am I going to do? A half is 0.5. So 0.5 times 3 plus 2. Okay, I can get the same thing. So don't use that as an excuse to not do it. You can do it. It just might take a little while. Hopefully give you a little incentive to start working on getting those lines set. So 1, 2.5, we're going to be open. So you can see how close they get together sometimes. And then I just plot the rest of the points. 2, 3, 3, 3.5, 4, 4. Let's play connect the dots. So that's what you've got to fight with. And if nothing else, now, tonight, this afternoon, whenever, okay, out of that assignment, there are only 4 graphs. The rest of them are like plug-in, like we did at the start. I beg of you, as soon as humanly possible, you have got to do 1 or 2 of these, because otherwise you're going to come in tomorrow and you're going to go, I don't know how to do any of this. And I'm going to go, grr, did you do one? No. And then I'm going to show you the quote again. So please, make sure you've at least tried some things with this. We'll have some answers up. I've already got the answer key in here if you even want to try one quick now and see if it's right before you go. And then we'll be doing some more with this, but we're also going to build on it some. So you've got to work on this. Again, last one on the homework check, and I'm done yammering.